Hello and welcome to this MOOC course on control system. I am Professor Keshav Misra and I will be taking this course as part of this subject as part of MOOC course. My department is Electronics and Communication Engineering, SIIT Bhopal. That is the part of prestigious SAES group. As far as syllabus for this MOOC course is concerned, I have divided in two parts, module 1 and module 2. The remaining part I will cover in module 3, 4 and 5. Module 1 contains basic concept of control system, classification, types of control system, examples of control system. And second part is transfer function related concept. We will also cover some numerical problems on this part. Syllabus for module 2 contains time response analysis for first order and second order control system. We will also determine the steady state errors and error constants. In second part of this module 2, I will cover PID controllers. We will also discuss numerical on various concept. These are some reference books I would like to suggest, and as per your convenience, you can take one or two. You can refer one or two. All are very good books. As far as control system is concerned, it is described as combination of components or network of components connected in such a way so as to perform some specific function. Say for example, simply you can take electrical fan. That electrical fan contains mechanical as well as electrical components, and whenever we apply the input signal that is in electrical form, we get the output in mechanical form. Simply, mechanical and electrical component constitutes the electrical fan. Other examples you can take washing machines, that is the traffic control signal. And recently India has purchased S-400 from Russia. That is also automatic guided missile system. That is also an example of automatic control system. This figure 1 represents typical control system where input is given, processing will take place here in control system block diagram, and we will get the corresponding output. These are the 4 components for control system: plant, feedback, controller, and error detector. Plant is basically actual processing unit, and to this unit controlled signal is generated by controller. Feedback is also second part of this basic control system. Feedback is basically link from output to input. In closed loop control system especially, we will use feedback link with feedback elements that will continuously observe the output. If there is variation in output, that will be informed to input side with the help of feedback. Error detector, whatever we get from feedback, that will be compared in error detector with reference input. And the last component is controller. This is the unit which actually controls the processing unit or plant. So this is the classification of control system. We can classify the control system in 4 ways. One is continuous time and discrete time control systems. As name implies, continuous time control signal will respond to continuous time signal. Continuous time signal, say for example, sinusoidal signal or continuous time signal are signals which can be defined for every instant of the time. So control system responding to continuous time signals are classified as continuous time control system. In context to continuous time signal, another control system is discrete time control signal. They will definitely respond to discrete time signal. Discrete time signals are one which can be defined only at some specific instant of the time. By the process of sampling, we can convert the continuous time signal into discrete time signal. Another category of control system is CISO and MIMO. CISO stands for single input and single output control systems, and MIMO for multiple input and multiple output control systems. Last category is very useful. That is covered in our module 1 and module 2, open loop and closed loop control systems. Open loop, as name suggests, there is no feedback path associated with such control signal. And for closed loop control system, there is provision of feedback from output to input. This is the one diagram representing the open loop control system. There is no feedback path from output to input, or we are not making any loop around the open loop control around this control system. So input, which is applied to controller will produce the controlled signal, or this is also called actuating signal. This actuating signal will control this plant or processing unit, and finally we will get desired output. This is a representation of closed loop control system. This is very useful concept. This is also called automatic control system. This is also called automatic control system. It means they can take care of any variation at the output. Accordingly, it can adjust the output with the help of this loop. This loop is provided around the open loop. This part makes the open loop control system: controller followed by plant or processor. In closed loop control system, reference input is here. This represents the error detector. This part represents the error detector. To this error detector, we compare the reference input and signal coming from the feedback path. So basically, this is closed loop. This is taking the some fraction of output, or we can say the output is sampled with the help of feedback elements, and the resultant signal is feedback signal. This feedback signal is compared at error detector. There is minus sign and this is plus sign, indicating that this minus sign is indicating that feedback is given in negative way. There are basically two types of the feedback. One is called positive feedback. Then we will replace this negative with the plus sign, and this is negative feedback, where we are adding the signal in this way. So one example I would like to quote here. We have already studied amplifier where the gain stability in gain is must. So in order to achieve the stable gain, we use negative feedback. And positive feedback we apply to oscillator. So we have made the provision of feedback here in order to compensate the variation in output because of external noise, because of external disturbances. Disturbances we can automatically correct with the help of this closed loop, that is the making the feedback control system. So this is since it can automatically correct the variations in output, this is also called the automatic control system. Here we, advantages and disadvantages for open loop systems are given. Open loop system, advantages of open loop system. There is simply input given to plant and resulting signal is output. So obviously complexity is not present in open loop system. So they can be designed easily, and obviously they are inexpensive. Only limited components are required for the open loop systems, so they are easy to design, inexpensive, but one problem is there. They cannot take any corrective action. In fact, open loop systems are stable also. But as far as disadvantages of open loop systems are concerned, inaccuracy is there, and unreliable. They cannot take corrective action because no feedback link, no feedback mechanism is provided in the open loop control system. So these are the two disadvantages associated with open loop control system. We can also discuss the advantages and disadvantages of closed loop control system. Additional components we are using as compared to open loop system, so definitely system cost will increase, will also finally that will also result in increase in complexity. But one major advantage associated with the closed loop system is the capacity to take automatic action to compensate the variation in output because of external effects, because of external noise. But they are expensive and complex if we consider the disadvantages. So closed loop systems are complex and expensive compared to open loop system. They are not stable. Stable means here if we provide the bonded input, results output should also be bonded, but this closed loop system may lack in stability point of view. So another disadvantage with closed loop control system is reduced gain. As I have quoted the example of amplifier, if we take stability is required, but it is on cost of reduced gain, because overall gain with feedback in amplifier is basic gain, amplifier gain is divided by some factor. We will discuss in some coming classes this concept, how the closed feedback system can reduce the gain also, but stability we can achieve. So this is the comparison of open loop and closed loop control system. Sometimes in examination, this question is asked, compare open loop and closed loop systems. So I have presented a table here to compare both the systems. The points we have already covered. Feedback path is not available in open loop control system. This is available in present. This is present in closed loop control system. Open loop system are easy to design, easy to construct, but closed loop systems are difficult to construct and design. Open loop systems are inaccurate because they cannot take any corrective action. Compared to open loop, closed loop system is accurate system. And here are some examples of control system. As I have already discussed, S400, or here we have taken Pinaka Mark III. This is automatic guided missile system with enhanced range. This is the very popular weapons of Indian Army. Traffic control systems and automatic water level controller is also example of control system. This automatic water controller can take care of overflow. Accordingly, it will take the action to on and off the electrical motor. And this is the traffic control signal. Lights will be on and off as per the traffic control situations here. So this is automatically designed. So all these are basically automatic control system. Closed loop system we can refer. So this is just idea of basic concept of control system types and classification. In coming classes, I will cover transfer function, numerical examples, some problems. So thank you very much. See you in next class. Thank you.